I want to talk about your brand new book, which also is at the intersection of both of those fields. It's called The Laws of Thought: The Quest for a Mathematical Theory of the Mind. Fascinating. And in it, you trace the history of logic and statistics from George Boole to modern AI to define the fundamental laws that govern both biological and artificial intelligence. In this book, you open by noting that we're fluent in understanding the physical world, but far less so the mental one. Do you want to tell us a bit about that?
One of the surprises that people might have is that we're used to thinking about using math to describe how the physical world works. So if you go to school, you might take classes in chemistry or physics, you learn the laws of nature. And the premise of the book is that there's a complementary set of ideas that really originated around the same time that people were thinking about these laws of nature being sort of mathematical principles describing the external world. And those are what we could call the laws of thought, the mathematical principles for describing our internal world. And some of the same people who are interested in, using math to make sense of physics and these other kinds of things were just as interested in using math to understand how minds work. It just took a little bit longer to figure out how to solve that problem, really up through the 19th century until we had our sort of first glimmers of what solutions might look like, and the 20th century to turn that into an empirical science, what we call cognitive science.
There's this word that's coming into my head as you've been speaking. And so I did an undergrad in neuroscience and a PhD in neuroscience, but it was a long time ago. And I was focused on machine learning applications to the field of neuroscience. So this word coming into my head, I don't know how relevant it is here, but psychophysics.
Yeah, psychophysics means the sort of intersection between psychology and physics that happens around perception. Right. So if you think about what perception is, it's the marriage of these two things. Like your visual perception, a photon comes into your eye and hits your retina, right? That's a physical process. But then you perceive that as a flash of light. That's a psychological process. And that was actually one of the places where the science of psychology started out, was trying to make sense of these kinds of, interactions between the physical world and our subjective experience. So the earliest psychology labs ran experiments where they would ask people to kind of report back what they experienced when they were experiencing different kinds of physical stimuli. And the rest of the science of psychology really evolved from that point.
Right. So the psychophysics is really about perception, these kinds of first layers of neural processing. In your books and in your research, it sounds like in general, you're more focused on deeper interplay. Our subconscious or conscious thoughts, the continuous flow between our frontal lobe and our other sensory lobes, and being able to have some kind of organized understanding of the world.
Yeah, so those first psychologists really, as I said, we're trying to characterize what was happening with perception, but we're also interested in what's happening in thought. But it turned out that thought was a much harder thing to study. And so at the start of the 20th century, another group of psychologists said, in fact, relying on people's subjective experiences here, if we want to understand things like thoughts and feelings, that's not going to get us very far if we want to have a rigorous science. And so they said, let's get rid of those things. This is a movement called behaviorism. Let's just focus on the things that we can measure. So we can measure people's behavior. We can measure the environments that they're in. And that's the route that we're going to have to making a rigorous science. And so they kind of just got rid of all of the things that I'm interested in, these kinds of internal processes of thought and so on. And so part of the story that's told in the book is the story of how we got past that and got to the point where we could have a science of the mind. And it was really using mathematics that made that possible. So ideas like logic and the development of computers gave psychologists a new language for being able to talk rigorously about things like thoughts, and a way of expressing precise hypotheses about how thoughts might work and how language might work and things like that. And so that then resulted in a new way of doing a rigorous science of the mind. And that's, the foundation for the kind of work that I do, where we ask these questions about the connections between human minds and computers.